Transactions. A typical enterprise application accesses and stores information in one or more databases. Because this information is critical for business operations, it must be accurate, current, and reliable. Data integrity would be lost if multiple programs were allowed to update the same information simultaneously, or if a system that failed while processing a business transaction were to leave the affected data only partially updated. By preventing both of these scenarios, software transactions ensure data integrity. Transactions control the concurrent access of data by multiple programs. In the event of a system failure, transactions make sure that after recovery, the data will be in a consistent state. The following topics are addressed here. What is a transaction? Container-managed transactions, bean-managed transactions, transaction timeouts, updating multiple databases, transactions in web components. Further information about transactions. What is a transaction? To emulate a business transaction, a program may need to perform several steps. A financial program, for example, might transfer funds from a checking account to a savings account by using the steps listed in the following pseudocode. Begin transaction, debit checking account, credit savings account, update history log, commit transaction. Either all or none of the three steps must complete. Otherwise, data integrity is lost. Because the steps within a transaction are a unified whole, a transaction is often defined as an indivisible unit of work. A transaction can end in two ways: with a commit or with a rollback. When a transaction commits, the data modifications made by its statements are saved. If a statement within a transaction fails, the transaction rolls back, undoing the effects of all statements in the transaction. In the pseudocode, for example, if a disk drive were to crash during the credit step, the transaction would roll back and undo the data modifications made by the debit statement. Although the transaction fails, data integrity would be intact because the account still balance. In the preceding pseudocode, the begin and commit statements mark the boundaries of the transaction. When designing Enterprise Bean, you determine how the boundaries are set by specifying either container-managed or bean-managed transactions. Container-managed transactions. In an Enterprise Bean with container-managed transaction demarcation, the EJB container sets the boundaries of the transactions. You can use container-managed transactions with any type of Enterprise Bean, session or message-driven. Container-managed transactions simplify development because the Enterprise Bean code does not explicitly mark the transaction's boundaries. The code does not include statements that begin and end the transaction. By default, if no transaction demarcation is specified, Enterprise Beans use container-managed transaction demarcation. Typically, the container begins a transaction immediately before an Enterprise Bean method starts and commits the transaction just before the method exits. Each method can be associated with a single transaction. Nested or multiple transactions are not allowed within a method. Container-managed transactions do not require all methods to be associated with transactions. When developing a bean, you can set the transaction attributes to specify which of the bean's methods are associated with transactions. Enterprise beans that use container-managed transaction demarcation must not use any transaction management methods that interfere with a container's transaction demarcation boundaries. Examples of such methods are the commit, setAutoCommit, and rollback methods of Java. SQL. Connection or the commit and rollback methods of javax. JMS. Session. If you require control over the transaction demarcation, you must use application-managed transaction demarcation. Enterprise beans that use container-managed transaction demarcation also must not use the javax. Transaction. User transaction interface. Transaction attributes. A transaction attribute controls the scope of a transaction. Figure 43-1 illustrates why controlling the scope is important. In the diagram, method A begins a transaction and then invokes method B of bean 2. When method B executes, does it run within the scope of the transaction started by method A, or does it execute with a new transaction? The answer depends on the transaction attribute of method B. Figure 43-1 Transaction Scope. A transaction attribute can have one of the following values. Required requires new mandatory not supported supports never. Required attribute. If the client is running within a transaction and invokes the enterprise beans method, the method executes within the client's transaction. If the client is not associated with a transaction, the container starts a new transaction before running the method. The required attribute is the implicit transaction attribute for all enterprise bean methods running with container-managed transaction demarcation. You typically do not set the required attribute unless you need to overwrite another transaction attribute. Because transaction attributes are declarative, you can easily change them later. Requires new attribute. If the client is running within a transaction and invokes the enterprise beans method, the container takes the following steps: suspends the client's transaction, starts a new transaction, delegates the call to the method, resumes the client's transaction after the method completes. If the client is not associated with a transaction, the container starts a new transaction before running the method. You should use the requires new attribute when you want to ensure that the method always runs within a new transaction. Mandatory attribute. If the client is running within a transaction and invokes the enterprise beans method, the method executes within the client's transaction. If the client is not associated with a transaction, the container throws the transaction required exception. Use the mandatory attribute if the enterprise beans method must use the transaction of the client. Not supported attribute. If the client is running within a transaction and invokes the enterprise beans method, the container suspends the client's transaction before invoking the method. After the method has completed, the container resumes the client's transaction. If the client is not associated with a transaction, the container does not start a new transaction before running the method. Use the not supported attribute for methods that don't need transactions. Because transactions involve overhead, this attribute may improve performance. Supports attribute. If the client is running within a transaction and invokes the enterprise beans method, the method executes within the client's transaction. If the client is not associated with a transaction, the container does not start a new transaction before running the method. Because the transactional behavior of the method may vary, you should use the supports attribute with caution. Never attribute. If the client is running within a transaction and invokes the enterprise beans method, the container throws a remote exception. If the client is not associated with a transaction, the container does not start a new transaction before running the method. Summary of transaction attributes. Table 43-1 summarizes the effects of the transaction attributes. Both the T1 and the T2 transactions are controlled by the container. A T1 transaction is associated with the client that calls a method in the enterprise bean. In most cases, the client is another enterprise bean. A T2 transaction is started by the container just before the method executes. In the last column of table 43-1, the word none means that the business method does not execute within a transaction controlled by the container. However, the database calls in such a business method might be controlled by the transaction manager of the database management system. Table 43-1 Transaction Attributes and Scope. Transaction Attribute Clients. Transaction Business Methods. Transaction Required None. T1 T2 T1 Requires New. None. T1 T2 T2 Mandatory. None. T1 Error. T1 Not Supported. None. T1 None. None Supports. None. T1 None. T1 Never. None. T1 None. Error. Setting transaction attributes. Transaction attributes are specified by decorating the enterprise bean class or method with the javax, EJB, transaction attribute annotation and setting it to one of the javax, EJB, transaction attribute type constants. If you decorate the enterprise bean class with transaction attribute, the specified transaction attribute type is applied to all the business methods in the class. Decorating a business method with transaction attribute applies the transaction attribute type only to that method. If a transaction attribute annotation decorates both the class and the method transaction attribute type overrides the class transaction attribute type. The transaction attribute type constants shown in table 43-2 encapsulate the transaction attributes described earlier in this section. Table 43-2 Transaction Attribute Type Constants Transaction Attribute Transaction Attribute Type Constant Required Transaction Attribute Type Required requires new Transaction Attribute Type Requires new Mandatory Transaction Attribute Type Mandatory Not Supported Transaction Attribute Type Not Supported Supports Transaction Attribute Type Supports Never Transaction Attribute Type Never. The following code snippet demonstrates how to use the Transaction Attribute Annotation. Transaction Attribute Not Supported. Stateful Public Class Transaction Bean implements transaction. Transaction Attribute requires new public void first method. Transaction Attribute required public void second method. Public void third method. Public void fourth method. In this example, the transaction bean class's transaction attribute has been set to not supported, first method has been set to requires new, and second method has been set to required because a transaction attribute set on a method overrides the class. Transaction attribute calls to first method will create a new transaction, and calls to second method will either run in the current transaction or start a new transaction. Calls to third method or fourth method do not take place within a transaction, rolling back a container-managed transaction. There are two ways to roll back a container-managed transaction. First, if a system exception is thrown, the container will automatically roll back the transaction. Second, by invoking the setRollback-only method of the Edge context interface, the bean method instructs the container to roll back the transaction. If the bean throws an application exception, the rollback is not automatic but can be initiated by a call to setRollback only, synchronizing a session bean's instance variables. The session synchronization interface, which is optional, allows stateful session bean instances to receive transaction synchronization notifications. For example, you could synchronize the instance variables of an enterprise bean with their corresponding values in the database. The container invokes the session synchronization methods after begin, before completion, and after completion at each of the main stages of a transaction. The after begin method informs the instance that a new transaction has begun. The container invokes after begin immediately before it invokes the business method. The container invokes the before completion method after the business method has finished but just before the transaction commits. The before completion method is the last opportunity for the session bean to roll back the transaction by calling setRollback only. The after completion method indicates that the transaction has completed. This method has a single Boolean parameter whose value is true if the transaction was committed and false if it was rolled back. Methods not allowed in container-managed transactions. You should not invoke any method that might interfere with the transaction boundaries set by the container. The list of prohibited methods follows: the commit, set auto commit, and rollback methods of Java. SQL. Connection: the get UserTransaction method of javax. EJB. Edge context: any method of javax. Transaction. UserTransaction. You can, however, use these methods to set boundaries in application-managed transactions, bean-managed transactions. In bean-managed transaction demarcation, the code in the session or message-driven bean explicitly marks the boundaries of the transaction. Although beans with container-managed transactions require less coding, they have one limitation: when a method is executing, it can be associated with either a single transaction or no transaction at all. If this limitation will make coding your bean difficult, you should consider using bean-managed transactions. The following pseudocode illustrates the kind of fine-grained control you can obtain with application-managed transactions. By checking various conditions, the pseudocode decides whether to start or stop certain transactions within the business method. Begin transaction. Update table A. If condition X, commit transaction, else if condition Y, update table B, commit transaction, else rollback transaction, begin transaction, update table C, commit transaction. When coding an application-managed transaction for session or message-driven beans, you must decide whether to use Java database connectivity or JTA transactions. The sections that follow discuss both types of transactions. JTA transactions. JTA, or the Java Transaction API, allows you to demarcate transactions in a manner that is independent of the Transaction Manager implementation. Glassfish Server implements the Transaction Manager with the Java Transaction Service JTS. However, your code doesn't call the JTS methods directly but instead invokes the JTA methods, which then call the lower-level JTS routines. A JTA transaction is controlled by the Java EA Transaction Manager. You may want to use a JTA transaction because it can span updates to multiple databases from different vendors. A particular DBMS's Transaction Manager may not work with heterogeneous databases. However, the Java EA Transaction Manager does have one limitation. It does not support nested transactions. In other words, it cannot start a transaction for an instance until the preceding transaction has ended. To demarcate a JTA transaction, you invoke the begin, commit, and rollback methods of the javax. Transaction. UserTransaction interface. Returning without committing. In a stateful session being with bean-managed transactions, a business method must commit or roll back a transaction before returning. However, a stateful session bean does not have this restriction. In a stateful session bean with a JTA transaction, the association between the bean instance and the transaction is retained across multiple client calls. Even if each business method called by the client opens and closes the database connection, the association is retained until the instance completes the transaction. In a stateful session being with a JDBC transaction, the JDBC connection retains the association between the bean instance and the transaction across multiple calls. If the connection is closed, the association is not retained. Methods not allowed in bean-managed transactions. Do not invoke the getRollbackOnly and setRollbackOnly methods of the Edge context interface in bean-managed transactions. These methods should be used only in container-managed transactions. For bean-managed transactions, invoke the getStatus and rollback methods of the UserTransaction interface. Transaction timeouts. For container-managed transactions, you can use the administration console to configure the transaction timeout interval. See starting the administration console. For enterprise beans with bean-managed JTA transactions, you invoke the setTransactionTimeout method of the UserTransaction interface. To set a transaction timeout, in the administration console, expand the configurations node, then expand the server config node and select transaction service. On the transaction service page, set the value of the transaction timeout field to the value of your choice, for example, 5. With this setting, if the transaction has not completed within 5 seconds, the EJB container rolls it back. The default value is 0, meaning that the transaction will not time out. Click Save. Updating multiple databases. The Java EA Transaction Manager controls all enterprise bean transactions except for bean-managed JDBC transactions. The Java EA Transaction Manager allows an enterprise bean to update multiple databases within a transaction. Figure 43-2 and Figure 43-3 show two scenarios for updating multiple databases in a single transaction. In Figure 43-2, the client invokes a business method in bean A. The business method begins a transaction, updates database 10, updates database Y, and invokes a business method in bean B. The second business method updates database E and returns control to the business method in bean A, which commits the transaction. All three database updates occur in the same transaction. In Figure 43-3, the client calls a business method in bean A, which begins a transaction and updates database X. Then bean A invokes a method in bean B, which resides in a remote Java EA server. The method in bean B updates database Y. The transaction managers of the Java EA servers ensure that both databases are updated in the same transaction. Figure 43-2 updating multiple databases. Figure 43-3 updating multiple databases across Java EA servers. Transactions in web components. You can demarcate a transaction in a web component by using either the Java SQL connection or the javax transaction UserTransaction interface. These are the same interfaces that a session being with bean-managed transactions can use. Transactions demarcated with a user transaction interface are discussed in JTA transactions. Further information about transactions. For more information about transactions, see Java Transaction API 1. 1 specification, HTTP, Oracle, COM, Tech Network, Java, Javali, Tech, JTA 138684, HTML,